8.5, we're testing the difference of means and the difference of proportions. We must have independent samples when we do this. Independent means there's no relationship between the values of each of the groups. So you're looking at two separate groups. We don't have a before and after anymore. It's two separate groups. So for example 8, a teacher wishes to compare the effectiveness of two teaching methods. Students are randomly divided into two groups. First group is taught by method 1, second group by method 2. At the end of the course, a comprehensive exam is given to all students, and the mean score X bar 1 for group 1 is compared with the mean score X bar 2 for group 2. Are the samples independent or dependent? You have two separate groups of students. They are not being tested before and after. You have one group and you have another group. Two separate groups means independent. Then, for the second one here, we'll do this one together too. So in section 8.4, we considered a situation in which a shoe manufacturer claimed that for the general population of adult U.S. citizens, the average length of the left foot is longer than the average length of the right foot. To study this claim, the manufacturer gathers data in this fashion. 60 adult U.S. citizens are drawn at random. For those 60 people, both their left and right feet are measured. Let X bar 1 be the mean of the left, and X bar 2 be the mean of the right. Are X bar 1 and X bar 2 distributions independent for this method of collecting data? They are not independent, they are dependent, because you're looking at the same person, their left and their right foot that you are comparing. So they would be not independent. So again, to run these tests in 8.5, you must have two groups that are independent. So they're not going to be the same people in both groups. They're two separate groups that you're going to be looking at. We're going to have 3 different tests as we go through this. The first test is when we know our sigmas. When you know sigma, remember, that's a z-test. Again, when you know sigma, that's a z-test. Now, when we write these, we have a specific way that we're going to put them in for our null and our alternate hypothesis. When you look at your null, you're going to say the two groups equal each other. Every single time, two groups equal each other. This is how WebAssign's going to have it too. So I'm trying to use the same notation that you're going to see on WebAssign. Then for your alternate, you're either going to say one group's bigger, smaller, or they don't equal to each other. So you have mu1 and mu2. Don't just say mu and mu. You have to actually write mu1 and mu2 with it when you write it. Mu1 goes on the left, mu2 always goes on the right. So for your null hypothesis, it will always be mu1 equals mu2. Doesn't matter what numbers you have, mu1 equals mu2. Now, just like before, you have a lot of steps you could go through to find things by hand, but you can use a calculator. I'm going to show you all the steps for your calculator. As long as you remember them, you will do fine using your calculator with these. The problem will be it's going to be a little more complicated with our two groups than it is for the one group. So you have to find a different type of test now because we have two, not one. So here would be our two sample z-test if we know our sigma. Again, we do a two sample z-test if we know our sigma. So it's pretty much the exact same thing except you have to do two of everything. Two sigmas, two x bars, two n's. So for example 9, a consumer group is testing camp stoves. To test the heating capacity of a stove, it measures the time required to bring 2 quarts of water from 50 degrees Fahrenheit to boiling. 2 competing models are under consideration. 10 stoves of the first model, 12 stoves of the second model are tested. The following results are obtained. Assume that the time required to bring water to a boil is normally distributed for each stove. Is there a difference between the performances of these two models? Use a 5% level of significance. Now, if you notice these two groups, we have a different number of people in both, or a different number of stoves in both. Whereas in the dependent samples, we had the exact same number in the first group as in the second group. But with these two independent samples, it doesn't matter how many you have in one group or the next because they're independent of each other. So you might have two different ends when you go through these, and that's okay. So your level of significance, 0.05. Your null, like I said, every time. mu1 equals mu2. Now we are testing that there is a difference. So if there's a difference, we're saying mu1 doesn't equal mu2. Remember, the doesn't equal is always a part of our difference. Now we got to go to our calculator. So we're going to go to our stat, over to test. Now remember what we're trying to look for. We want to find the two sample z-test. So look for two sample z-test. So it's number 3 for me. And now we're going to fill in all of our parts. So still have stats dark, but fill in your parts. So our sigma 1 is 2.5. And because you have so many numbers, double check them, because I have to double check myself too, because I might be typing things into the wrong one. X bar 2. You got your N2. And we are does it equal. So you're going to hit your calculate. They're going to give you a lot of numbers there. The main thing is we need our z and our p, just like we did before. So our z is 1.28. And then our p is 0.2008. So now we're going to compare that with our alpha. Remember, p goes on the left, alpha goes on the right. We have a greater. Whenever it's greater, we're going to fail to reject. So again, when we go through this, we need to make sure we write our sentence. So we are at the 5% level of significance. There is, remember we have to add that word not enough evidence to conclude that there is a difference in the population mean times for boiling water for the 2 stove models. Remember, we always start the same. Tell me your level of significance. Either there is enough or there is not enough evidence, and then to conclude, and then state what you're trying to find in the problem. So I want you to do the next one here. So I'll read it over to you, and then find all your parts. So let us return to example 8 at the beginning of the section. A teacher wishes to compare the effectiveness of 2 teaching methods for her students. Students are randomly divided into 2 groups. First group taught by method 1, second group by method 2. At the end of the course, a comprehensive exam is given to all students. The first group consists of N1 equals 49 students with a mean of X bar 1 of 74.8 points. The second group has N2 equals 50 students with a mean score of X bar 2 equals 81.3 points. The teacher claims that the second method will increase the mean more on the comprehensive exam. Is this claim justified at the 5% level of significance? Earlier research for these two methods indicate sigma 1 is 14, sigma 2 is 15. Let mu1 and mu2 be the mean scores of the distribution of all scores using method 1 and method 2 respectively. So you are going to go through and do all these parts and we'll come back together. So pause the video, go through this one, and then I'll come back with you. So for this then, we should have a level of significance, 0.05. Our null, remember, is always the same. But now they are saying that the teacher claims the second method will increase the mean score. If the second method is going to be greater, we need to have mu1 is less than mu2. Now we have our data, so we're going to go through and run our tests. So stat, test, 2 sample z-test. So my sigma 1, they said, is 14. My sigma 2 is 15. Oops. 15. My x bar 1, we've got 74.8. My n1 is 49. My x bar 2 is 81.3. And my n2 is 15. We are looking at less than. And we go down to calculate. So when I go through that, your z should be negative 2.23. And your p is 0.0129. So we're going to compare that with our alpha. Alpha is going to be on the right. P-value's on the left. So we are less than. If we're less than, we're going to reject the null. So now when I write my sentence, you're not going to include the not. So you have everything but the not to it. So we say there is enough evidence to conclude, and then finish it, to conclude that the second teaching method increased the population mean score on the exam. Again, you're finishing your sentence somehow based off of what the question is they're asking you. I'm going to stop this video now, come back to the next one for part 2 then for us.